Hi, Ryan.
Okay.
We'll get started here in a minute or so.
Hey.
Morning, Eric. Like your background.
Thank you. One of my favorite cars. My favorite classic cars.
Nice. Morning, Sophia.
The 1949 Buick Roadmaster.
Nice. We'll be getting started here in a moment. Morning, Shane. We'll be getting started here in a second.
All right.
The first thing I would like to do before I get started, take a moment and look at the Zoom meeting down near the bottom. You'll see reactions. Can you guys, because every once in a while we're gonna do a problem and then I'll ask, hey, do you guys have any questions or anything? Can you click on the reactions? If everything's okay, I kind of would like you to give me a thumbs up. So can you go ahead and give me a thumbs up now? Yeah, kind of thing. All right, okay. All right. All right, so I'm going to go ahead and get started then. I'm going to share my desktop with you. Okay, so today we are continuing to whiteboard worksheet 3. So in the calendar, today's Tuesday. We're whiteboarding worksheet 3. So when you click on this link here, we've already done the first 3 problems. So you guys are period 6. And by the way, if you would like to be in, like Lita and Sophia, you guys like to work together. So if you would want to just work in one of these, you don't have to work by yourself if you don't want to. You can if you want, but you don't have to. But you're going to be working on problem number 4. So I want to talk about it before we start working on it. So the first thing you're going to do, you're going to sketch a picture. So you kind of read through the problem, ignore the numbers. A man pushes a child in a grocery cart. The total mass of the car of the child is such and such. If the force of friction is given, how hard does the man have to push? Okay, so I just kind of left off all the numbers to cause it to accelerate. So you kind of sketch a picture of what that looks like in your head. Then you read through the problem and figure out, is it balanced or not? And your hint is that it says it accelerates, so that's your hint. And then you're going to draw a force diagram. That's with the arrows and stuff to represent that. And then finally, you're going to solve it. And the way you're going to solve it is you're going to be using these equations up here. And that's it. So I think I would want to give you about 5 minutes to work on it, and then I'll kind of show you how to do it if you're stuck. I understand you probably can't get it done in 5 minutes. Just do the best you can. So let me stop sharing. All right, so go ahead and work.
Am I exiting? Okay, there it is.
Hi, Liam. What we're doing now is if you go to the Canvas calendar and you click on Physics First and you go to Tuesday. Right now we are whiteboarding worksheet 3, problem number 4. And so when you go in here, you'll pick period 6, and then you would pick your folder, and then you'd pick problem 4. Oh, wait a second, you couldn't see any of that. Sorry, I need to share my desktop with everybody. Sorry about that. Let's go back here. I apologize. I think There was somebody else wanting to get in. So Zakira, Liam, is Liam still here? Oh, Liam left. Okay, Zakira, let me show you what we're doing right now. So I need to share my desktop. So if you go to the Canvas calendar for today and you look at Tuesday, we are whiteboarding worksheet 3. So if you click on this, click period 6, and then go ahead and click your name, and then we're working on problem number 4. Okay. Actually, you don't need to go ahead and get started on it though, because I gave students about 5 minutes, and now I'm going to go ahead and show students how to solve it. Okay. All right. So this, if you're not done already, why don't you just kind of stop for a second, and I'm going to show you how I solved it. I actually didn't have time to solve the whole thing, so I just want to show you what I did. I actually went online, so yeah, this is not fun that we're not in the classroom, we're not with one another, but there are some cool things about using the internet. I just simply typed in man pushing grocery cart. Oh, I like that stick figure one. Anyway, so I found one that I'm like, yeah, that's sort of right. So I kind of did a snipping of it and I pasted it in. For this one, it says that it's accelerating. So let me circle that. It's accelerating. That would mean it's unbalanced, so that when I draw the force diagram, the normal and the weight balance, but the push force is bigger than the friction force because it accelerates. So I've done already steps 1, 2, and 3 over here. Now all I have to do is solve it. And the way I solve it is I use these equations up here. So F net equals ma, it's the equation we just found in the recent lab we did last week and before break. And the other equation, Fg equals m times 10, that's one we found at the very beginning of the unit. So I'm going to start with that first one, Fg equals mg. So in the force diagram, Fg is going to be equal to m times g, which is 10. And it says in this problem that the mass is 30 kilograms. So it's going to be Fg is equal to 30 times 10. And then I break out my handy dandy calculator. Or actually, that was not too bad, right? That's a pretty easy one to do in my head, probably. And what do you get when you multiply that out? 30 times 10.
300.
300, yeah, thank you, Eric. And since it balances out the normal must also be 300. Equals 300. It says in the problem right here, that the force of friction is 15 newtons. So this is equal to 15. And in order to figure out what the push is, because that's what it wants to know, how hard does the man push? In order to figure that out, I have to use the second equation, this F net equals ma. So I'm going to do that work over here. F net equals m times a. Again, the mass is 30. So I'm going to put 30 times the acceleration is 1.5. So I need somebody to get a calculator for me because I haven't done this yet. 30 times 1.5. What you get for 30 times 1.5?
45.
45. Thank you, Sophia. So was that right? Was that Sophia? Was that Zakira? Who was that? That was Sophia. Okay. So 45. Okay, now I want you to understand the push force is not 45. So when there's a net force, it's kind of like when your parents do their taxes and they're figuring out the net income. that means they have to add up all the sources of money. You know, your dad makes money, your mom makes money, maybe even you make some money, right? Babysitting or, you know, mowing or something. You have to figure out the total money going in, and you have to look at the total money going out. For the force diagram, you got 300 newtons for the gravity force, but that's downward, and it exactly cancels out the normal 300. So the net force between those two is 0. For the friction force, it's 15, and it's smaller than the push force, which means the push force has to be 15 plus 45. So I'm going to do another calculation over here. Push is equal to 15, that's the friction, plus the 45. Because it's got to be bigger than the friction. There has to be a net of 45. And so again, somebody with calculator, 15 plus 45.
60.
60, thank you. I think I was Ryan, so 60. So this is push 60. So any questions on that? Okay, let me stop sharing. So remember how at the very bottom there's reactions? Are we all good? Thumbs up. Can you give me a thumbs up for the reactions at the bottom down there? If you understand it, thumbs up. The reactions. So if you look at the bottom of your screen, there's reactions there. So if you get that, can you hit the thumbs up at the very bottom? Sophia, you good? I'm not seeing a thumbs up. Oh, there it is. Okay, okay. So I think I haven't seen it from Liam. Liam, you have any questions? Liam, any questions? Liam, you there?
Yeah.
Okay, any questions, or did you get that? Does that make sense?
Yeah, my bad. It was on
Okay.
me.
Can you hit the thumbs up down at the bottom, Liam? Do you see the reactions? See the reactions at the very bottom? It has a little smiley face, and there's like a clap, and there's a thumbs up. So yeah, thank you. Okay. All right, thanks. All right, so the next problem we're going to be looking at, let me share with you. So that was number 4. So the next one we're going to do is, I'll get there eventually. Okay, number 5, and number 5 kind of looks like this. A 3-kilogram cart on a track is pulled by a string so that it accelerates. The force of tension is given. What's the force of friction? So what I would like you to do is sketch a picture, read the problem, figure out if it's balanced or not. Again, your hint is it says that it accelerates. So that's your hint to figure out if it's balanced or not. Then draw a force diagram, and then finally solve it. And again, the way you solve it is you're going to be using these equations here. So I think real quick, I think I want to explain to Liam and Zakira, I'm not sure if she was able to hear this or not, what we're doing right now. So if you go to the calendar, you click on physics first agenda. If you go scroll down to Tuesday, and it says here we're working on worksheet 3, you click on this here. And of course you guys are period 6, so you click on period 6. And inside here is a folder with your name on it. And we're doing right now problem number 5. So click on that problem number 5 and just start whiteboarding. Okay. So I'm going to stop sharing, and I'm going to give you guys about 5 minutes to work on it. Okay. So you guys all doing okay? I didn't ask you that. I should have asked that first. You guys doing okay at home? Yeah.
Yeah. Doing good.
Anybody doing anything interesting? This weekend I went to Chino Lakes State Park. Has anybody ever been there? It was totally free. It's not that far away. It's really, if you like nature, you like going out in the woods and stuff, it's really, really nice. There's not hardly any people there. It's kind of cool. It's neat. I recommend it. It was totally free. It was open, didn't cost any money. I don't know if it still is open and free or not. You can't camp there, but you could walk through the woods and stuff. It was really nice. So I recommend it.
I've been there.
Have you? Yeah.
Once
can't-
saw
I'm
once
sorry.
when I was there, I saw a catfish.
Really?
I saw a catfish, actually a dead catfish, being eaten by a turtle on the shore. It was the weirdest thing, most random thing ever.
There's lots of trees that are kind of knocked over from beaver. I mean, I didn't see any beaver out there, but you could tell there must be a lot. So, um,
You
it
ever
was
been,
kind
you
of
ever,
nice.
you ever been to Brown County?
I have it. I went to IU for my teaching degree, and yeah, it's kind of nice down there too.
There's actually poisonous snakes down there.
Oh,
Actually.
really?
Yeah, there are a few, there are copperheads that live down there. It's within the range.
All right, I'm going to go ahead and get started on this problem. I know you're probably not done, but that's okay. All right, so let me share what I've got. So again, I kind of went online and I found this picture over here on the right of this cart. So I just kind of stole it to make it a lot easier. And you know what's neat is this force diagram I actually kind of stole for the last one. I selected it. I just kind of went like this, selected it. I went Control C for copy, Control C is copy. And then I just clicked on this one, went Control V for paste. So it was kind of nice. I had to change some things, like it's not a pull force anymore. There's a string, so it must be tension. But it's kind of, you know, it's not fun not being together, but I mean, it's kind of nice that you can do some of this stuff online. Okay, so I've done parts 1, 2, and 3 because it says that it's accelerating, so it's unbalanced. Now I just have to solve it. And the way I solve it is these two equations up here. And I'm going to start off with the gravitational force. So that's m times 10. It says that the mass of the cart is 3 kilograms. So I'm going to make this 3 times 10. And that's 30. So that means the normal force would be 30. So I've got those two. Let's see. It says that the string has a tension of 10 newtons. So I actually know what the tension force is. That's 10. That's equal to 10. Okay, in order to figure out the friction force, I know it's less than 10, but in order to figure it out, I have to calculate what the net force is. So that's the F net equals ma. So I'm going to write that equation over here. F net equals m times a. And again, it says the mass is 3. So it's going to be 3 times the acceleration, it says, is 2. So it's 3 times 2, which means that the net force is 6. That doesn't mean the friction's 6. No, the friction is not 6. So the net force, so looking at the normal and the gravity force, those two cancel. So the net force between those two is 0. But the tension force is bigger than the friction force. In fact, it's bigger by 6. So if I want to find the friction, I have to take 10 minus 6. And that will give me the friction. So force of friction, can't spell, sorry, equals 10 minus 6. Oh, that one's an easy one. 10 minus 6 That's 4. So the force of friction is 4. That's the answer. Because it wants to know what is the force of friction. That was a question. So you'll notice we kind of had to do a lot of work. I kind of think of these problems. I don't know if you ever played Sudoku. Sudoku, it's not like you know what the answer is and you put all the numbers in just like that. You kind of have to fill in a little bit here, then you fill in a little bit here, you fill a little bit here, and eventually you get it all filled in. Same thing here. I wasn't able to get my answer of 4. I had to do all this other stuff first. I had to draw the force diagram. Actually, I sketched a picture, draw a force diagram, write my F net equals MA, and then finally I was able to solve it. That's kind of how physics is. All right, one more problem, then that's it for today. So let me show you this last one. The last one is number 6, and it looks like this. So here we have a shopping bot. I can't speak. A shopping bag, and it evidently will start to rip when we have a force bigger than 65 newtons or bigger. The shopper puts 5 kilograms of groceries in the bag and tries to lift the bag so that it has an upward acceleration of 2 meters per second and it wants to know, will the bag break? So the first thing I want you to do is sketch the picture, read the problem and figure out if it's balanced or not. And here is your clue. It says it accelerates. Then draw a force diagram and then finally solve it. Okay, so I'm going to stop sharing and give you about 5 minutes. Okay. Okay, so I know you're probably not done, but I don't really want to take more than about a half an hour. And it's been close to a half an hour, so I think I'm going to stop you. And I know you're probably not even close to being done. But I want to go ahead and show you what I got and finish it up. That way it doesn't take more than half an hour. Okay, is that okay with everybody? Okay, I'm going to share my screen. Okay, so here's my picture. I don't know what that thing is in her hand. It must be some kind of new device. That's kind of a neat idea. I always hate that, holding those plastic bags. It kind of hurts my fingers after a while. Anyway, so she's lifting this up and has an acceleration upward. And the force diagram actually is a little bit easier. There's only two forces. There's this force downward, force of gravity. I didn't really know what to call the force upward. You could call it a pull force if you want. I call it tension. I don't know. I don't know what to call it. But anyway, there's two forces. And the force upward is bigger. It's accelerating. So it's not balanced. So I've just done steps 1 through 3. Sketch a picture. Figured out that it was not balanced because it accelerates, and then drew the force diagram. Now I'm going to solve it. And again, the way I solve it is with these two equations. So the force of gravity would be equal to m times 10. And it says in the problem that the shopper puts 5 kilograms in the bag. So that means it would be 5 times 10. And, oh, that's another kind of easy one. 5 times 10, I think, is 50, isn't it? Is that right, 50? Yeah, good. Okay, 50. To figure out the tension force, the tension's not 50 because look at that arrow, it's much longer. I have to figure out what the net force is. So I have to do an equation over here, net force, F net. That's going to be equal to m times a. That's what we found in our lab that we started right before break and then finished up after break. So m again is 5. And a, the acceleration is 2. So 5 times 2, that's an easy one. That's 10. Okay, so that means that the tension is bigger than the gravity force. And if you're like, how much bigger? Well, it's 10 bigger. So to figure out the tension force, F of tension, it's going to be 10 bigger than the gravity force, and the gravity force is 50. So it's going to be 10 plus 50, which that's 60, right? Good, everything 60. So the tension force is 60. And now we can answer the question. The question wants to know, will this bag break? Notice it says that the bag breaks once it gets up to 65 newtons. So will the bag break? Can you guys unmute yourself? Tell me, will the bag break?
No.
No, good, yeah, nice.
No.
So I'm gonna, actually, can you guys use the little thumb thing at the bottom? Tell me if you agree, thumb, no problem, you understand it, bag does not break? Okay, okay. Yeah. Okay, all right, thanks, I'm gonna stop sharing then. So we're all good, and I just need to, wait a second, what do I need to do? Oh, I know, I have to share, sorry, I have to share again. I have to talk about then what people who are not watching the video have to do. You guys don't have to do this because you're here actually in the Zoom conference, but the people who are actually going to have to watch this video of the Zoom conference, they need to do this attendance quiz. You guys don't need to do it because you're actually here. So I know that you understand this stuff. But I need to give those people the code, so don't go anywhere yet. The code for it is here. It's EV, both of those are capital, EV, and then lowercase YAN 7976S. And you guys can do it too if you want. In fact, tell you what, I'll let you guys get bonus if you want. It's just the same stuff that, it's very similar to what we just did in whiteboarding today. So if you're like, yeah, I totally get this stuff easy, you can get bonus points if you want. So it's totally up to you if you want to do it or not. So again, that code to get into that quiz is capital EV, lowercase YAN, 7976S. Okay, so I'm going to stop sharing. And that's it. Our next conference, if you look at the calendar, the next conference, Zoom meeting, will be on Thursday. And we'll finish up this worksheet. Again, it's at 9:20. Any questions? All right, you guys stay safe. See you later. Bye.
Bye.